Let's explain two's complement. So two's complement is used to represent the negative value, used by Larry to represent the negative value. So for example, at the beginning, we just represent all the positive values. In this case, if I have 4 bits binary number will have a range from 000 to 1111, which is 0 to 15, total 16 numbers. Now, but those are any positive. So how about if I want to represent the negative number? I cannot do it, right, in this format. So the scientists found a new way to represent the number, new system. This new system number is this. It will use the first bits to represent the sign. So the first bit is sign bit. So if the first bit 0 means positive, 1 means negative. So in this case, you have 4 bits, then what you can represent? Let us see what happened. So the largest positive number will be 0, 1, 1, 1, right? This is the largest integer which is 7. Now, after you have 7, then you say, oh, well, naturally from 7 you minus 1, you will get a 6. So 0, 1, 1, 0 is 6. Then 0, 1, 1, 1, 0, 1, this is 5. Then 0, 1, 0, 0, this is 4. 0, 0, 1, 1. Every time you minus 1, this is 3. Then you have 0, 0, 1, 0, this is 2. 0, 0, 0, 1, this is 1. Then you have 0, 0, 0, 0. This is 0. Now, how about the negative number? So what will be negative 1? Well, there are 2 ways to understand this. One way is you naturally think I use 0, 0, 0 to minus 1, but I really cannot minus 1, so I have to borrow 1 from a line exist bits. Suppose it exists there. Equivalent say you suppose there is a positive number is 1, 0, 0, 0, 0, then minus 1. Then the result will give you 1, 1, 1, 1. So it's very natural to think this is negative 1. This is one way. Another way is I use 2's complement. Okay, so 2's complement for the negative 1 is I start from 1. So what is 1? 1 is 0, 0, 0, 1. I start from 1. 2's complement you can get by this. Your box way is you flip every bit, then you add 1 to it. So if I flip every bit, we get 1, 1, 1, 0. Then add 1 to it, so we get 1, 1, 1, 1. Now this is one way to get a 2's complement. So 0, 0, 1, this is 1. 1's 2's complement is negative 1. So which is 1, 1, 1, 1. This is negative 1. This is one way to do. Another way to get a 2's complement is this. So start from here. I start from the rightmost. If it is 0, ignore it, don't change. Move to left until meet the first one. No change. After that, flip every bit. Now, what I mean? So I start from rightmost, which is this one. If it's 0, but this is not 0, this one, but this is my first one. So first one, I keep it, I don't change. I have first one, I keep it. Then I move to the left. For every other sense, after the first one, everything I flip it over. So I got 1, 1, 1. So this is negative 1. So you use 2's complement of 1 is negative 1. The same thing, how can I get if I have this value. I want to know what it is its value. Like if I have 1111, I want to know what is his value. First, I look at this first digit, which is the first bits. Leftmost bits is 1, so I know it's active. So it is active. If it's active, then what I'm going to do, I say I use 2's complement. Say what is its 2's complement in positive value. Now, how I do that? I start from rightmost one, rightmost bit. Since it's 1, no change. The rest I flip it over. So this is 1, no change. I move to the left. Everything else I flip it over. So its 2's complement is 001, which is so original number is negative 1. Now let us give another example. For example, I want to know what is the representation of negative 6. So I start from positive 6, which is 0110. This is positive 6, right? This is positive 6. So it's 2's complement. I use the rule we just did. I start from rightmost bits, 0, no change. 0, no change. Then first one, no change. And the rest move to the left, flip it over. So it's 0, 1. So this will be negative 6. Okay? This is negative 6. Now, also you can start from this table every time you minus 1. So negative 1 minus 1, this is negative 2. Then negative 2 minus 1, right? So this is negative 3. Negative 3 minus 1, this is negative 4. Negative 4 minus 1. I mean, when you do minus 1 like this, you treat everything as positive value, just like you did the positive number minus. So you minus 1 will be this. This is negative 5. Negative 5 minus 1 is 10, 10. This is negative 6. Negative 6 minus 1, negative 7. Negative 7 minus 1, this is negative 8. So you say if you use 4-bit number system to represent, you use 2's complement format, which means the first bits is the sign bits. You will have the number ranges from negative 8 to positive 7. So number range from negative 8 to positive 7. Okay? Now let us practice one more 2's complement. Say, how about if I give you this number, 1001, I ask you what is his value. Now, I say this is a 2's complement format. When I say that, you know the first bit is a sign, so this is a negative value. In order to understand what a negative value is, I found its 2's complement, which is I start from the rightmost bit, which is 1. I don't change it. Then move to the left. Every time I flip it over. So 1, I don't change it. This I flip it over, so become 1. This flip it over, become 1. This flip it over, become 0. So 0, 1, 1, 1, I know this is 7. If this is 7, so the original number is negative 7. Okay?